welcome to the Spiceworks Trainer demo video. I'm Alex, and I'm going to be speaking to you today, teaching a little bit about VPNs. What is a VPN? A VPN is a virtual private network. It allows us to connect two disparate networks through a third insecure network by a secured tunnel. So anything that normally goes through the internet from my one location here to my other location here is normally up for grabs. Anybody can see it. By adding a VPN, we can create a secure tunnel that's encrypted, and all of our data travels through the internet through that. It securely allows us to communicate from point A to point B. There are two types of virtual private networks. The first one, and the most common one, is a routed virtual private network. This is almost exactly like you see with a router between two disparate networks, allowing them to communicate. You have your broadcast domain of your main LAN, and then all your virtual clients are on a second broadcast domain coming through your VPN server. This does is it segments the network and only allows traffic destined for either your main network or a VPN client to go through it. The other one is a bridged VPN. A bridged VPN is the same as taking your laptop and plugging it into a wall Ethernet port for your LAN. Exactly like that. It looks and acts, except for the latency and speed issue, exactly like you were plugged into the network physically or connected by Wi-Fi. You would get the same IP address as on that LAN network, and you'll be able to see and act with all the other computers exactly like you were on that network based on your access rights. Now, you might ask, why are there two different types of VPNs? Well, a routed VPN is the one most commonly used, and it's relatively smart to segment your VPN traffic from the rest of your LAN traffic. But there are case scenarios where a bridged VPN is very beneficial or even needed. For instance, where I work, we sell Rockwell automation equipment like programmable, PLCs, programmable logic controllers. There's software that's sold to work with these PLCs that can detect them, program them, and so forth like that. Some of this software requires that the software and the devices be in the same broadcast domain. So, let's say your controller computer is a laptop with the software on it, and you're an engineer, you take it home. You get a call at 3 o'clock in the morning and you have to look into the system. Instead of having to drive in and connect to the network, you can connect in by a bridged VPN to that production network and now use your software tools to configure, check the equipment. The normal VPN for our users at my company, I've also set up as a bridged VPN. Primarily I do this so that, one, I can still track their internet usage, the stuff that comes through us over the gateway by IP address. They get the same IP address with their laptops by VPN as they do when they're in here physically, because it uses the same DHCP server, so it obtains the same lease. So that helps me keep track of their internet usage. Additionally, I run some network bandwidth tools, and I can use a tool like IFTOP so that on the virtual tap device installed in the server to actually see what the activity is currently going on between my network and my remotely connected client. Now, the two big players I see frequently in VPN, and you've probably heard of both of them, is the Microsoft routing and remote access, which is also called but uses point-to-point tunneling protocol Point-to-point tunneling protocol is actually just PPP, the same protocol used in dial-up days. And what it does is it encapsulates your traffic in a PPP capsule, and that's and encrypts it using GRE. And this is a good example of a traditional routed VPN. The other big example I see for VPNs, outside of hardware VPNs, is OpenVPN. OpenVPN is an SSL, or a secure socket layer, encrypted virtual private networking suite that's cross-platform across your major 3 platforms, basically all of your Unix-based like operating systems, Windows and Mac. And it will do either bridged or routed VPN. The one thing I like about, well, not the one thing, there are lots of things I like about it, but one of the things I like about OpenVPN over RRAS in Windows is that you can have multiple authentication mechanisms with it. Like RRAS traditionally uses just a username and password combination, whereas OpenVPN, because it's SSL based, can use SSL certificates just like you do when you talk to your bank, and you can identify individuals like that. In addition, you can use username and password combinations to enhance security. However, Microsoft routing and remote access offers a good advantage too, and that advantage is that the client is built into every Microsoft Windows machine. It's just your dial-up networking, and it's a special adapter. Whereas with OpenVPN, you have to install additional software. Everything is a drawback one way or the other, has pros and cons. I'm looking for a 5-minute video here, and it's up to 7 minutes. So let me wrap up this section 1 on VPNs. Just to recoup, a VPN is a virtual private network. It's encrypted traffic between 2 networks that need to talk to each other securely over an insecure network like the internet. Part number 2. There are 2 primary types of VPN services: routed and bridged. Routed separates traffic from the VPN and the local LAN. Bridged makes the VPN an extension of the local LAN. Finally, the 2 major contenders out there right now that most people see, aside from hardware implementations of VPNs, are point-to-point tunneling protocol, Microsoft Server, and OpenVPN cross-platform VPN server. So I hope you've learned something. Hope you have a good day, and thank you.